So this is actually two questions you asked me, and I'm trying to answer them with one problem. Find the Norton equivalent here, and the other question that Nick asked, can you do one on maximum power? So I just added that resistor at the end. And the question, what value of R sub L I will need here to maximize my power? Well, we know we need R for maximum power transfer. You need R sub L to equal R Thevenin. Well, since R Thevenin is equal to R Norton, so you need R sub L to equal R Norton. So that's the first one. Maybe we'll calculate the maximum power delivered to it too while we add it. So now let me Thevenize or find the Norton equivalent, not Thevenin, Norton equivalent of this circuit. Yeah, Nortonize, I guess. And since I have both independent and dependent, again, some books will say put a voltage source or a current source here. If you put a voltage, find the current going through it and divide them. Or if you put a current source here, find the voltage and divide them, and that's your answer. I do them a little bit differently. I said if you have dependent and independent, you need V open circuit and I short circuit. So this is my circuit, again. .7 amp. $1.5K, that's 1,500. And this is 2,500. And I need V open circuit right there. Which is equal to V Thevenin. Oh, we're doing the Norton equivalent, I'm sorry. We're doing Norton equivalent, right? I still need that anyway. Why? Because R Norton is V open circuit over I short circuit. So it doesn't matter if I do I Norton first or I short circuit or this one first, so I'll stay with that one. And we can use any method you want to here. Notice since I sub x is the current down like this, let me define I sub x, that's this current, is the current coming down this way. And let me define I sub y, you want it clockwise or counterclockwise? Clockwise, okay. So V Thevenin is going to equal to what? 1,500 times I sub y. So if I can find I sub y, I'm done. It's the voltage drop right here. I know the resistor 1,500. I know this current I sub y. So let's see if I can write a couple of mesh equations. Well, I can't use this as a closed loop. Why? We don't know what the voltage here. I can't use this one either. I don't know what the voltage here. So I have to go with what? The outside. Try to be colorful here. How about if I travel this way? You want to travel clockwise or counterclockwise? Clockwise. So I'm going to take the outside loop here.
Are you traveling the same way?
Clockwise, like this.
Why is your arrow the other way?
Huh?
Why do you have arrows showing?
This one?
No, your pink arrows, they're both showing.
Yeah, going this way. You loop. No, I'm traveling in the loop this way. Oh, no, I see what you're saying. Yeah. Yep, I got you now. Yep. Yep, I'm going clockwise. I got you now. I mean, like this, right?
Yeah,
Yes.
they're going the same.
Okay. Too early. So let's begin with this. The voltage drop as you go in this way, that's plus to minus 1,500 I sub y. plus to minus 2500 I sub y. Continue up here. That's going to be what? Negative 500 times what? I sub x. And this is what?
Plus 2 x.
Is that just 2 or 2k? Yeah, I guess 2. Let's clean that. I have 1,525, is that 4,000?
Yep.
4,000 I sub y minus what? 498 I sub x is equal to 0. That's one equation. I need a second one. That current source, the 0.7 amp. Notice both of these currents going to combine which way going? Upward. So I sub y, if you look at it, add to it I sub x is going to equal to what through that so? Negative 0.7. Very good. Because they're both pushing up. That's my second equation. Two equations by two unknowns. So simultaneous equation, two of them, 4,000, negative 498, 0, 1, 1, negative 0.7, and I got I sub y here to equal negative 0.0775, and I sub x equals negative 0.6225. Do we know what Thevenin now, or V open circuit? What's V open circuit, which is Thevenin? 1,500 times I sub y. 1,500 times I sub y, which is negative 0.0775, negative 116.25 volts. So that's the first part of the problem. I define V open circuit plus on the top, minus on the bottom. It says it's negative. So when I'm looking for I short circuit, I want it down, coming down. So let me now find I short circuit. Again, the same circuit. I know I make them sometimes capital letters, sometimes small letters. And now here, you're going to put a wire, and we're looking for that current coming down I short circuit. What is that I short circuit, that wire, going to do to the 1,500 ohm resistor? That's gone, right? That resistor is gone. So my circuit will look Now I'm looking for this current I short circuit. So let me define this current I short circuit. And let me define this current I sub x the way it's labeled. Again, if I take a loop on the outside, travel clockwise, traveling in this direction, there'll be a voltage drop right here, plus to minus 2500 I short circuit. This will be what? Minus 500 I sub x plus 2 I sub x equals to 0. 2500 I short circuit minus 498 I sub x is equal to 0. That's the first equation. And again, what's my second equation? If I take I short circuit and add to it I sub x, they're both pushing up through this one, coming up, should equal what? Negative 0.7. So now I can solve for I short circuit and I sub x. I could care less about I sub x, but the one I need is I short circuit. And let's see what these numbers are. There we go. 2500, negative 498, 0, 1, 1, negative 0.7. Solve it. I short circuit is negative 0.1163, and I sub x is negative 0.5837. Do I know our Thevenin now? Which is our Norton? It's V open circuit over I short circuit. What was my V open circuit? Negative 116.25. What is my I short circuit? Negative 0.1163. 116.25 divided by point.
That was off by 3 decimal points, so I must have just.
999.6. Is that 1,000 roughly?
Yeah, about that.
I got 999.6. So that's 1,000 ohm.
Alright.
So that's your R.
That's RL. You want that's R7, which is R Norton. That's also for maximum power transfer. You want it to be R sub load.
Yep.
So now you want the Norton equivalent. The first question, what's the Norton equivalent? It's I Norton, which is negative 0.1163. You can convert that to milliamp if you want to. In parallel with 1,000. And this is your R sub L now.
Wait, you can,
That's the Norton.
so it's a current supply, not a power supply.
Yep. If you want the Thevenin, it's the V open circuit, which is the negative 116.25. 1,000 ohm. And this is R sub L.
So that's the Thevenin and that's the Norton.
Yep.
One side. So the only.
That's a source transformation, actually.
Well, yeah, I see that.
Yes.
but,
If you take this divided by that, you end up with that number. Yep, so that's why once you know one, you know the other one, source transformation.
So technically, we can do a whole problem in Thevenin and then just transform.
Do a source
it,
transform,
and
yeah,
then
sure.
We lose points in the exam.
Well, if you have independent, dependent source, it doesn't really matter where you do it, you still need to find V open circuit and I short circuit. So you have both of them sitting right there at the tip of your finger. This is V open circuit, which is V Thevenin. This is I short circuit, which is I Norton. You have both of these, and you have R Norton, R Thevenin.
Norton's the one with the current source in parallel with
Yep.
with the resistor.
So for my maximum power transfer, I asked a question for maximum power transfer. To answer next question now.
Can you do both by chance? Both? I know it's gonna be
Yeah,
the same thing. but-
doesn't matter. So R sub L is going to equal to 1,000. And what's the power? Maximum power is going to be V Thevenin squared divided by 4 times R sub L. What's V Thevenin? Negative 116.25 squared divided by 4 times 1,000, which is 4,000. Negative 116.25 squared divided by 4,000, which is negative 3.
Can't be negative.
I mean, a positive. Square it, yep. Did I square it? Actually, I did square it, yep. It's 3.37. I'm just looking to see if there's milli there, but it's not. 3.3785, how about 38 watts? If I was doing that circuit, I need to find the current through that. And the current through I sub L is going to be half the current. These resistors are equal. So I sub L is going to be half of I short circuit. Remember, power equals I squared times R. So in this case, I sub L squared times R. Well, what is I sub L? Isn't that half of this current? When these guys are equal, it's going to be half of that. So it's I short circuit divided by 2 squared times R sub L.
Wait, I short circuit because the resistors are in parallel.
No, that's this current's called I short circuit. So that's what? I short circuit squared times R sub L divided by 4. And I bet you if I plug in those numbers, negative 0.1163 squared times R sub L, which is 1,000, divided by 4. Let's see if it's the same answer. 0.1163 squared times 1,000 divided by 4, 3.38.
So that's, you divide by 2 always since the resistors are
Equal, yep, it's going to split in half. Same thing right here. This is V Thevenin. This is I Norton, or I short circuit. Yeah.
It's showing you two different ways. You
Yep.
calculate the power.
Yep. Because if you know the current instead of the voltage,
You don't
it's
have
I
to-
squared times R. And I here will be half of that current because they are equal. Just like V here will be half of this because they are equal. So it's going to be I squared or I Norton squared divided by 4 when you square that times R sub L. My back. My back. So you hear me making noises, that's my back. It's killing me. I'm trying not to scream. It's been like this for a while. It's just certain movement. Well, I made it worse. I had the guys in the gym trying to pull on me. Wrestling coach, and now I can't move. Gonna kill him. He should kill me. But I'm the stupidest to go ahead and do it. So if you hear me making noises, it's just me when I go to move certain ways, like, somebody just stabbed me in the back with a knife.
Can we possibly work one problem, like you're giving us a problem, and we try working it out?
Well, you can do after the class. Can't use the class time. I gotta get it on the video. Go ahead.
One more question? Or-
Go ahead. Hurry up.
Yeah, it's on the next page, or wait, no. Yeah, next page. It's the figure 5.83. I just want to see.
What page?
168. I just, like, how do you do it when you have... When
160,
you have to add a source,
168. Number, which one?
It's just that figure right there.
I think it's 42.
It gives me 42. You don't have to do it now.
42. Yep, that's all right.
If you're
I s-
adding in a,
Yep, your circuit, I'm gonna redraw that circuit. It looks a little bit ugly there. So I have this circuit again. That turns sideways because I'm holding the book sideways, so it makes it easy for me to see what it looks like. And that's 0.11 times what? I can't read that number. The bottom.
VAB.
That's the top. We'll call it VX. VAB is too many things to write. $11 ohms. $30.
20.
That's 20. Okay. Plus to minus 0.5. I'm assuming that's VX again, VAB, right? And that's 15. And we're looking for the equivalent of that, and Vx is right here. This is really Vx. Since you only have dependent sources, I said you can either add a voltage source or a current source. It really doesn't matter which one you add. It's up to you. But I'm just looking at this. If I add a voltage source or a current source, if I do a voltage source, I know what Vx here. So I can tell you what these values are.
You can just choose whatever.
Yep, you can choose. So maybe I'll do that. Let me add a voltage source and pick a value for it, any number you want to. Usually we try and pick some reasonable number like 1 volt, because it makes the math easy. But the value itself doesn't really matter.
Because it's just proportional with
Yep.
whatever the dependence is.
So now you're going to find the current going this direction. Remember, when you have only dependent sources, V Thevenin, which is V open circuit, that's a 0. It's not even there. You don't have that. All you have is R Thevenin. And how do you find R Thevenin? You take the voltage source that you put in, the value of that, which is 1 volt, and you divide it by the current I. So if I know what the current I is, I know what R Thevenin is. Now the good news is by putting 1 volt here, what's Vx now? Try again. 1 volt. We know what that is. 0.5. We know what that is. 0.11. They're no longer unknowns. So by putting that 1 volt source, now this dependent current source now has a value of 0.11 amp.
I could do a source transformation.
I could, yep. And this will be what, 15? I could do source transformation, or I can just write color equations by color unknowns. Now, if I decide to go in this direction, what's this current now equal to?
Negative.
Negative what?
0.11.
Try again.
Wait, with the voltage or
The current.
the current?
Isn't that pointing in the same direction as this?
Yeah.
Same direction, going up there, right?
So wait, when it's pointing in the same direction, it's going to be same.
Yeah.
Okay, no, you know what confused me is because from one of the other problems, there was a different type
Yep.
of situation.
If I do KVL here, two equations by two unknowns,
So,
and I sub 2 equals negative I. Go ahead.
so just to clarify, like when you're doing mesh analysis and you have an independent current source or dependent current source that you know the value of, that current will be the current of that mesh.
Because that's the current going through the outside loop. That's what I sub 1, just like, this I. This I is the current going through this, the current through that, not through this. Through this is going to be what? This one pushing down, this one up. So through this coming down is going to be this minus that. Just like through this, if you're going up there, is going to be this minus this one. But that current is the current going through this, and it's current through that. It's not splitting. It's on the outside pieces. This current is the current going through this. This current is the current going through that up to here. So now I'll just do KVL. Do KVL here and KVL here. KVL, this one, I'll start with this. That's what? Let me use a different marker here. 20 times I sub 1 plus to minus plus 0.5. Let me find the current down. I'm going plus to minus plus 15 times the current down. What's the current down? I sub 1 minus I sub 2. Keep going. Current up plus to minus plus 11 times. Is that 11 that resistor was? Yep. And what's the current going up there? I sub 1 minus 0.11. Clean it. 20, 15, 35, 45, 46. 46 I sub 1 minus 15 I sub 2. 11 times a negative 0.11. That's negative 1.1 plus 5. That's negative 0.51, is it, I think? Is it 11?
Times 0.11. 0.121.
11 times negative 0.11. Negative 1.21. Then you got to add to it the plus 0.5.
1.7.
Negative 0.71. Move it to the right side, it becomes 0.71. So if we clean this equation correctly mathematically, that's it. And let's do KVL right here for this one. Plus 1. Again, I'm going out, traveling this way. It's going to mark it plus to minus. What's the current up there? Plus 15 times the current up, which is what? I sub 2 minus I sub 1 is equal to 0. Clean it. 15 I sub 1 minus 15 I sub 2 equals 1. I moved into the right side there already.
Can you move it up a little bit?
So now let's solve for I sub 1, I sub 2. The first one, 46, negative 15, 0.71, 15. Uh-oh. Let's go to the beginning. I hit some keys, I guess. The wrong one. 46, negative 15, 0.71. The second one, 15, negative 15, and 1. So what is I sub 1? What's I sub 2? I sub 1 is equal to negative 0.00935, and I sub 2 equals negative 0.076022. So what is I in relation to I sub 1? I mean to I sub 2? Opposite. So I is going to be what? I is going to be positive 0.076022. And what is R Thevenin? It's 1 divided by 0.076022. clear. 1 divided by 0.076022. And it's 13.15 ohm. So that's what R Thevenin for the circuit is.
So why did you reverse the polarity for I?
Because I is going this direction. I define I through the source minus the plus. I sub 2 is this current. So I sub 2 is backward to I, direction-wise.
Could you push the paper up a little
Yep.
bit? Yeah.
And you have to do I short circuit?
Nope, can't. There is no I short circuit here. V Thevenin is going to be only when you have when you only have dependent sources, you're going to have R Thevenin only. There is no V open circuit. There is no I short circuit. None of that stuff because V open circuit is 0.
So
You're not going to have.
if you were to make a Thevenin or Norton equivalent circuit of that,
It's going to be a resistor.
it would just be a resistor.
Resistor. That's it. A resistor of 13.15. So the equivalent, Thevenin equivalent Norton is only a resistor of the value of 13.15 ohm.